right. All right, let's try to finish this up. I got a couple pages of notes to go through, several pages, but some of it's kind of spread out, so hopefully we'll be able to get through this. All right, we got till 3 o'clock, right? So that should be plenty of time. Yeah. All right, so what we're going to do is talk about domain and range, all right? We kind of were talking about that yesterday. This is example 3. And this is part A. There's going to be 2 of them, and it says state the domain and range. You'll see this quite a bit, and we're going to be pretty much the rest of this lesson is kind of like that. State the domain and range, all right? Sometimes they're easier, sometimes they're not so easy. These are kind of easy right now. Yes, sir. That's fine. State the domain and range. Nope. It's example 3, section 1.1. You could figure it out pretty quick. All right, state the domain and range. So let's do this. And this is going to help us also with just kind of understanding what I'm asking for when I ask for what is the domain, what is the range. If it was an ordered pair, it would be super easy, wouldn't it? Which one is the domain? The x value, right. This would be the, oops, that's kind of weird looking. This is the domain, and then the y value is the range, okay? So when you think of domain, you're thinking of going along the x-axis. When you think of the range, you think of going on the y-axis. And it works out perfect because D is before R, right? X is before Y. So it just goes in alphabetical order so you know which one it is. So you shouldn't be confused on that. All right, let's do a little graph thing. So, oops, why is it crooked? There we go. There we go. All right, and let's change the color of the graph just so it doesn't blend in. All right, so what if I had just like a regular straight line graph? I thought it changed the color. There it is. All right, so here's the line. It's a line, so it's got arrows on the end. It keeps on going, that kind of thing. So what are all the values that are in the domain, or what are all the possible x values? That's what we're trying to find. When it asks for the domain, it's asking for all the x values. So, like if I took a point anywhere on here, okay, the x would be right here, wouldn't it? All right. Is that all the x values, though, for that line? No, there's an x value for that one, an x value for this one, right? There's an x value for every single point on here. So where does it begin and where does it end? What's the lowest number x value and what's the highest number x value? Remember, this is the x-axis right here. So think about this graph. Each one has a point associated with it. Agreed? All right. So think about just the x's. It goes, think this way. Here's the x-axis. It goes this way. What's the smallest x value? Like, is it? So the x value, 0 would be, actually 0 would be right here. Nope, sorry. Yeah, 0 would be that point right there. That's where x is 0. But there's smaller numbers for x, aren't there? I mean, because look, you got points here, point here, and you got points way, way, way down and keep on going where? How far? Forever, okay? So what's the lowest? We do. What's the lowest? What's the smallest number ever in the world? Negative infinite, right? Or negative infinity is what we would say, right? Negative infinity. So the x's go all the way to negative infinity. Would you agree? Yeah. How high do they go? Positive. They go to positive infinity, right? So I could go all the way out here and eventually I'm going to hit that graph, aren't I? Okay? So what are all the numbers from negative infinity to positive infinity? But we've talked about it. It's probably a word in the lesson. All the what? Not all the real numbers, right? Not just the integers, because the ones in between, right? You got numbers in between the integers. So it's all the real numbers. So what's the domain of a graph like this? It's all the numbers that are possible, okay? And we say real numbers because there are other types of numbers. Did we talk about that in here? I talked about it in my Algebra 2 class, the other period. What's another, if it's not a real number, anybody know? Did you learn this in Algebra 2? Probably not, but you're going to learn it here for sure. Have you ever heard of imaginary numbers? Okay, I thought it would be. So you did that in Algebra 2. Yeah, I kind of thought you would do that in Algebra 2. I wasn't sure. I haven't taught out of either this book or the Algebra 2 book before, so I don't have a great understanding of everything that's in the books. But it's all the real numbers. We're not talking imaginary numbers. That's completely different. But it's all the real numbers. So we would write this. The domain, this is how they like you to write it, equals, and then they write it as a set. So you put that little brace thing, and you put all the real numbers. Or you could put that weird-looking R. Did we do that? Man, I get confused on if we did it in this class or my other class. It's like it's like that. That's kind of how they do all the real numbers. Or you could just write out all the real numbers. I'm fine either way. Yep, you could do that fancy looking R thing. I don't know if it's got like a special name. Anybody did they tell you last year? I don't know. It's just a R, right? It's just an R like that. Okay, all the real numbers. That's what it is. Now let's think about the range. Now we're going to think the same thing, except we're thinking in what direction? Not the X direction, but the Y direction. All right. So let's think of this line and all the points that are associated with it in the Y direction. How far down does this go? Forever. So to where? Negative infinity. And how high does this go up? To positive infinity. So what's the range for this graph? Again, all the real numbers. So that's what they're asking you to find. Now, not every graph is a straight line like this, right? You did that in Algebra 2, didn't you do parabolas and stuff like that? Yes? Yeah. Little curved graphs, yeah. Some of you guys look confused. You did parabolas, didn't you?
Yeah. Well, we didn't specifically do it, but we did.
Where it looks like this?
Yeah.
Yeah, that's a parabola. Yeah, I thought you did. I figured you did. Anyway, for a straight line like this, it's all the real numbers. What if, now this isn't on the example, let's change colors. What if, I'm just making this up off the top of my head. What do I want to do? Hit that. What if it was a horizontal line? What's the domain? All the real numbers, because you're looking at the X value, right? How far does this graph go on the X? Forever. Forever this way. So it's all the real numbers, right? What about on the Y? What's the range of this thing? Right, it's just the number that it hits. Now we don't know what that number is. Let's make one up. What do you think? Where do you think that is? -4? Okay. We'll call that -4. So what's the range of that particular line? It's just -4, and that's it. That's the only place where it hits the y-axis. Everybody see that? It's like this point right here. This point could be like 7 what? -4, right? This point right here could be way out here. It could be -1,000, but what's the y value always going to be? -4. Do you see that? So the domain, or the range, I'm sorry, is always going to be -4 on something like that. Now, what if you had, again, this is not in the notes. This is free of charge. What if you had a graph like this? What's the domain of that yellow graph? Wherever it is. Yeah, I'll call it -3. That's good. So -3. Yeah, the domain is just -3. That's the only place where it hits on the x-axis, right? Every single point on that yellow line is going to start off with what? -3, comma, something. What's the something? What's the range of this yellow graph? Infinite. So what do we say? All the real numbers. That's right. So the range of this is all the real numbers. The domain is just -3. You understand what we're trying to find when we do domain and range now? Okay, with these kind of lines, it's kind of simple to understand. But there's going to be some other lines that are kind of weird. Do you have to go? You got to go somewhere?
Yeah.
All right, bring it up. I'm going to show you another one. That's part A. I'll show you another one. Come on, quick. I'm going to show you another one, which is part B. And it's a little bit different. You've probably seen it before. You remember absolute value, don't you? Do you remember how to graph an absolute value or what it looks like? Maybe not. All All right, that's fine. You just went through a summer. I get it. You're not going to remember everything. Let's turn this back to white. So let me do a little graph thingy here. That's good enough. And let's do the graph in a different color. Let's go this, I don't know, what do you like, that orange color? All right, so what if we had, yeah, we'll start there. There. And there. Try to make it the same.
Oh, okay.
That's actually an absolute value. We're not going to worry about that right now. Just look at it. That's all we're looking at. Okay, we're just looking at the graph and trying to figure out what are we trying to find on this? The what and the what? The domain and range, right? We're trying to find what the domain and range is. Okay, so the domain is along the x-axis. So what points are on this line? Like how far can we go to include every single point that goes along the x-axis? Now again, right here, these are all points, right? Points, points, points. They all have an x, don't they? All right? They all have a y as well, but what's true about all the x's on this side of the line? They're all negatives, and it just keeps on going forever. So what's my domain? It goes negative infinity. What is it on the right here? Positive infinity. So what is it from negative infinity to positive infinity? It's every single number, all the real numbers, okay? So the domain are all the real numbers. Yep. And let's just write it like this just to be a little different than what we did before. Put it in a set, all right? And it's all the real numbers. What about the range, though? The range is a little different. Is the range all the real numbers? No, because look, there's nothing below the x-axis, right? There's nothing below 0. So we can't include any negative numbers, can we? So what can we include? Just the what? Just the positive numbers, all the real positive numbers. So you could write it a couple ways. They write it all the non-negative numbers. I think it's kind of weird. You could just say all the positive numbers, right? I don't know why they wrote non-negative. That's what they did. And or you could say it like this. There's a bunch, several different ways you could do this. You could say all the numbers of y that are what? Well, it hits right here. That's a 0, isn't it? 0 is not positive. Greater than what? But greater or equal, right? Because it also includes that point right there, doesn't it? It includes 0. So we don't want to just say it's greater than 0. It's greater than or what? Equal to 0. All right? So you could write it like that. Or you could just say all the positive numbers. I think the book, because I wrote it down, I probably wrote it down what the book says. Yeah, all the non-negative numbers. That's weird. Right. In fact, I got to change that. I said all the positive numbers, but 0 is not positive, is it? Right. So yeah, you're right. That's probably why they say non-negative. So instead of saying all the positive numbers, including 0, right? That's a little wordy, but this is good right here. What I just did, I like that. But you could say all the non-negative numbers as well. All right. You get in the hang of it a little bit about what domain range is. All right, on to page 2, finally. Let's see, let's talk about this. We're going to be talking about this all year long. And if you take a college class, you'll be talking about it there. You probably talked about this in Algebra 2. I'll probably be saying that a lot. Did you guys do this in Algebra 2? It's called a function. Did you do functions? Yeah, you probably did a ton of that, didn't you? What's that? It's not an example, it's just a definition. I'm going to write it down. It's a little wordy, but let's write it down anyway because it's such an important word. We're going to be doing tons and tons of functions. It's actually not that hard to work with. All this definition stuff is kind of boring, isn't it? I like to get down and dirty and do the problem. I want to do a problem. I want to get an answer. I hate doing this definition stuff, but even though I hate it, it doesn't mean it's not important, okay? It's important, all right? Functions are important. So here it is. It's a relation. Remember what a relation is? It's like an x and a y, right? They go together. For each x, you get a y. It's a relation in which each element, should be writing this down, in which each element of the domain, so we kind of spent some time talking about that, of the domain is paired with, right? Remember a relation, you pair two things together, is paired with. Now this definition is not going to really make you understand what a function really is, but I think it's important. After you start doing functions, then you look back at the definition, you're like, oh, okay, now I see what they're talking about. You know, it's kind of one of those things. Is paired with exactly one element in the range. One element in the range. Basically what it's saying is each x has its own unique y associated with it. Okay? So that's kind of what they're saying right there. So let me give you an example. The example is going to make more sense than what the definition does. But then we do the example, we'll look at the definition, and you're like, oh, okay, I think I know what they're saying now after I saw an example. So this in the book is example 4. It says state the domain and range of each relation and then tell whether it's a function or not. Okay. So A. So here's what they do. They give you a few ordered pairs. They give you 3 ordered pairs. They give you -3, 0, 4, -2, and 2, -6. Okay. First of all, it says state the domain and range. That's super easy. So what's the domain of these ordered pairs? -3. Yeah. Yeah, let's go in. Usually they put it in order. So yeah, -3, 2, and 4 would be your domain. Good. What's your range then? -6, -2, and 0. Yeah, again, going in order from the lowest to the biggest, okay? I don't think technically you have to go from the lowest to the biggest, but it's usually just kind of common for us to do that, all right? And we have to see if it's a function. Look, each x, listen to what I said before, each x has its own unique y. You hear what I just said? So this -3 has a 0. This 4 has a -2. This 2 has a -6. Is each y unique to those particular x's? Yeah, they are. Okay, there's no like repeats or anything like that. Okay, so yes. So is this a function? That's the big question. Is this thing a function? Yes, it's a function. Yes, it's a function. All right, that's your answer right there. Yes. You could just say yes if you wanted to. All right. What about this one? So this time they put 4 ordered pairs. 4, -2. 4, +2. 9, -3. And -9, 3. All right, let's take a look at this. Let's look at the definition one more time. Relation, a function is a relation in which each element of the domain, so each x, is paired with exactly one element in the range. Each x has its own unique y associated with it. So let's take a look at this. This 4 relates to -2. This 4 relates to 2. What are you thinking so far? It's not a function, that's right, because this 4 goes to -2, but this same 4 also goes to 2. Is that unique? Is that one of a kind? No. Okay? It doesn't go to exactly one element in the range. Look, this 4 goes to -2, this 4 goes to +2. That's 2 things that 4 is relating to. 2 different things. Agreed? Yeah, even though positive, negative, I mean, they're still completely different numbers. So that alone, I could stop right there and say what? This is not a function. I don't even have to go any further. Just that one thing that's happening. So let's talk about this as far as the graph. This is going to lead us up to something here, I promise. Let's just graph those first 2, because the other 2 are fine. right? That 9 goes to negative 3. See, that negative 9 is a completely different number than 9, so it doesn't matter what it goes to. That's fine. It's this right here that messes us up. So, yeah, let's do this. So 4, negative 2. So there's 4, there's negative 2 right there. And then there's 4 and there's 2 right there. Do you see how they're on top of each other like that? If your points are on top, or directly on top of each other like that, that's not a function. Because, again, I'm leading up to something, I promise. All right? Because if I drew a vertical line, I was off a little bit there, but pretend it's right there, okay? So, let's do this. I don't know. It bugs me that they're not exactly the same. So let's make that bigger. Let's make that a little bigger. There we go. See how I drew a vertical line through both of those? That's called the vertical line test. If you can draw a vertical line through your graph, and if it hits 2 separate points, that means that x doesn't have exactly a unique y associated with it, right? So this x has one y associated with it, and that x has another y associated with it. That means it's not a function, because that goes against what our definition says. Would you agree? All right, it's got to have exactly one element in the range to that domain. All right, and that's going to be super helpful. That's called the vertical line test. We do that quite a bit. Let's write it down. Vertical line test. And so when they give you some graphs and they're going to ask you, is this a function or not a function? You can apply the vertical line test and see if it is or not. So we're going to do a couple examples like that. Let's move that. Everybody got that right there? So let's push that up a little bit. Let's move this. Okay, here we go. Now, I am going to, let's click off of that. All right. What if I had, so a function could be just a series of ordered pairs, right? Remember the example we did just earlier before the vertical line test? You know, you just had a series of ordered pairs, and they could make a function. All right, so let's say, I'm just making this up, this one, this one, this one. Is that a function? Well, what do? How do you test? How do you test visually to see if that's a function or not? Draw a vertical line, that's right. So let's do this yellow one.
Could you do the same thing with a horizontal line?
No, horizontal line test doesn't work, okay? Only vertical line test, because let's say, see, this is a negative x, whatever it is, and this is a positive whatever. Let's say that was negative 5 and that was positive 5. And if they relate to the same y, it's not the same x relating to the same y. They're two different x's relating to the same y. You're allowed to have that. You just can't have the same x relating to two different y's. Okay? So if I had a dot right here, then this would not be a function. Okay? But does this pass the vertical line test?
Yes.
Yep. I'm just gonna, oops. Yep. Let me grab that. And let's just move this around. Does that pass the vertical line test? Yeah, because there's nothing above or below it, right? Does that pass the vertical line test? Yeah. Are those 3 points considered a function? Yeah, absolutely, because they pass the vertical line test. All right. Here's what you're going to see a little bit more often. Oops. Forgot I copied that. Let's go back here and copy this again. Okay, there we go. All right, here's a crazy looking graph. Now you did parabolas. Did you do a thing called hyperbolas? Do you remember that at all? Where it's kind of, it's a kind of sideways parabola. Ooh, that was kind of ugly. It's close enough. All right. Did you ever do anything like that? We'll probably do stuff like that this year. Again, I say probably because I've yet to teach out of this book, right? And I haven't studied every lesson in this book, obviously. So, but I'm pretty sure we'll do stuff like this. Is this a function? That's the question. You should just be able to look at it and tell if it's a function. Why is it not a function? That's right. It does not pass the vertical line test. So I could put a vertical line anywhere on here, right? If even in just one place it doesn't pass the vertical line test, it's not a function. Okay? Well, there's a bunch of places it doesn't pass the vertical line test. Well, right there. See how it hits 2 spots on the blue line? Automatically, that rules it out. It's not a function. Now look, I could put the vertical line right here, and it only hits 1 point. Does that mean it's a function just because it hits at 1 point? No, it's got to be the entire graph, right? Anywhere on here, right? Anywhere to the left of that point right there, that just shows right there it does not pass the vertical line test. So this is what? Not a function. Now they don't put this on here, but I'm going to. Remember we talked about that parabola? Let's see if a parabola is a passes the vertical line test. All right, so I'll just kind of make it like this, like that, like that. Okay, there you go. Is that a function?
Yes.
Yeah, because everywhere I put a vertical line, let me draw a vertical line here. There's nowhere on here where you're going to hit 2 points, right? I could keep going. Now, of course, that goes on forever. Is it ever going to hit 2 points over here? Nope. Here, 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 here. Nope. It's only going to hit what? 1 point. Okay, that vertical line is only going to hit at 1 point, no matter where you put it on here. So, is this a function? Yes. This is a function. All right. All right.
What graph is that again?
That's called a parabola. We'll be doing those, I'm sure. I can almost guarantee we'll be doing those. All right. Oh, a couple more crazy graph things. Ooh, running out of time. All right, let's try to go a little quick. You're going to see some graphs that look like this. It's kind of weird looking. Let's do another color. Let's do green this time. I don't usually do green. All right, what if you had a graph like this and this, watch. Everything is shaded. This is supposed to be shaded in. So everything on that side of the line is shaded in. Okay? You get the idea? Okay. So everything over here is shaded in. So, is this a function?
Yeah. Well, I mean, it would be the line is common.
Remember, all this shaded in means those are points. Those are potential ordered pairs. Okay? Like if I put a point right here, that's an ordered pair. If I put a point right here, that's an ordered pair of my relation. All right? But is it a function, though? No, it's not a function because it doesn't what? Pass the vertical line test. Because if I drew vertical line right here, okay, there you go. It does not pass the vertical line test. Nowhere in here does it. Whoops. Come on. There we go. Nowhere in here does it pass the vertical line test, does it? All right, because it's going to hit a bunch of different places because it's all shaded in. Like every single point that you can imagine on this side of the line is in there, right? I've shaded in that whole entire area. So that is not a function. One more. Again, this is another thing that we're going to do eventually. I don't know. You did sine and cosine stuff, right? You did trig stuff last year, yeah. Did you graph any of that? Do you remember graphing like sine and cosine?
We didn't do any of that.
You didn't?
That's what you just said.
No. Last year in Algebra 2. You didn't do sine, cosine, and tangent last year? You only did it with me in geometry? Oh, my word. See, I was trying to prepare you for Algebra 2. I thought for sure you would do that in Algebra 2. All right, here we go. Yeah, I'm not trying to throw any teachers under the bus or anything, but it's definitely an Algebra 2 topic you should have done. You're definitely going to do it this year. You're going to do a ton of it this year, all right? And it's going to be all right, so watch this. I'm trying to make this as smooth as I can. I don't know. Yeah, that's close enough. All right, there we go. All right, here you go. It's a crazy looking thing. It's actually the graph of it's the cosine. Okay, that's the cosine graph. We'll get to it. Don't worry about it. But you don't even have to know anything about it. All you got to do is figure out, is this a function or not a function? So is this a function? Yeah, it is. Because anywhere you draw a vertical line, it's only going to hit 1 point, isn't it? All right. Why do I always think that's changing colors and it doesn't? There we go. All right, so look. Anywhere you put this, it's only going to hit 1 point on that graph. Would you agree? So is this a function? Yes, it's a function. All right, here we go. We got to talk. We're still talking functions, but now we're going to actually lead up to something we're actually going to do a little bit of math with, okay? So when we talk about something being a function, this is the notation that we use. And you probably did this last year. F of x. Do you remember that? Yep, f of x. That's how you say it. I'll put it in quotation marks. That's how you say it. It's not f times x. It's not, f is a variable and x is a variable. It's f of x. It's a function, all right? You could use other letters too, but usually we use f. Why do you think we use f? Because the word function starts with f, all right? But you can use any other letters, okay? G of x is another very common. H of x is another common one, but you can use any letter at all. Those are probably the most common ones that you'll see in books and stuff like that, all right? So let's make sure we see that. So a lot of times they'll say this, y is equal to f of x. So a lot of times we just kind of replace y. So for instance, if I said like y is equal to 3x plus 2, right? You've seen stuff like that. We've graphed stuff like that before, right? Slope, y-intercept. We did it in geometry. I know you did it in Algebra 2. You can't tell me you didn't do that, all right? So we could replace the y with what? F of x, okay? Now, back in algebra, probably Algebra 1, you had stuff like this. You had, what did they call it? Not substitute, replace. Oh, man, I should, not really. Evaluate problems. It'll say evaluate y equals that if, what do you think they told you? If what? If x was equal to, I don't know, 2. We'll go even easier. We'll go 2, all right? Remember doing these problems? So figure out what y is if x is equal to 2. So what'd you do? You went 3, or y equals, if I could write, 3 times what? 2 plus 2. 6 plus 2 is 8, so y is equal to 8. Now watch. All we're doing now with this function stuff is we're just changing the notation. So instead of saying y equals this, if x equals negative 2, we're kind of getting rid of all this right here. We're kind of streamlining it and making it a little bit easier to understand. It's really the same kind of thing that you did in Algebra 1. We're just changing the notation a little bit. So instead of y equals 3x plus 2, if x equals 2, this is what they would do. They would say, they would do this. They would give you f of x equals 3x plus 2. And then they would say, like part A, let's say, they would say find, now watch what they're going to do. They're going to say find f of 2. See what they just did? They just replaced that x with what? A 2. So what do you think you're going to do with this x? Replace it with a 2. It's the same exact thing, right? It's just how they ask the question is just a little bit different. That's all. Does that make any sense? Yeah. I know I'm talking a lot today, and some of you guys are doing really good, staying awake, but a few of you need to get your heads up and pay attention. All right, so here's what we do. So f of negative 2, what is that? So they'll just do that. They'll say find f of negative 2, and then part B, they'll say find f of negative 3, and whatever, okay? You with me on that? So you're taking this, that's your function. That's the f function. And then all you're doing is you replace this x with 2, so you're replacing this x with a 2. So the math is exactly the same. So you go 3 times 2 plus 2. 6 plus 2 is 8. There you go. And then over here, what would you do? You go 3 times what? Negative 3, right? Because that's the x. You replace the x with a negative 3 plus 2. What's that? Negative 9 plus 2 is negative 7. And that's kind of what you're going to do. All right, so now you have to start getting used to that. That's what you're going to see more than anything. When you get up at higher level math, they won't do this kind of thing. They won't say y equals this, if x equals 2, find what it is. All right, they're going to do it like this. This is going to be very common. After a while, you won't even think about it anymore. It'll be so second nature to you. It's not going to be that big of a deal. All right. I want to get this done. There's a couple examples they give you. They're a little bit harder numbers, but I think we're good with these examples, okay? So example 6, I think it was. let me see, where is it? Yeah, example 6 was pretty much this. It's just a little more difficult. Like it's 3x squared minus, or 3x cubed minus 7x squared minus 2x. But all you do is just replace, right? You just evaluate, you just substitute those in there. I just want to finish. I got less than 10 minutes, so let's try to get this done. All right, here's another one's kind of weird. They're going to do this. They're going to say, this is example 7. I skipped 6. If you really want to see 6, look at it. But it's just like what I did before, except just a little bit more complicated. All right, this one's a little bit different. So it says evaluate h of a. That's kind of weird, because normally they have like f of 2 or f of negative 3. But this time they're saying evaluate h of a if h of x equals, and then some big crazy thing. Don't worry about this. We're not really going to have to do any like real math. They just made it just kind of long and cumbersome, but it's really not going to be that way. So what does this tell us to do? That's all we're trying to figure out, okay? The math part of this is not hard whatsoever, even though you see x to the 7th. Don't worry about that. Because what are we replacing for x? An a. That's all we're doing. All we're doing is taking this a and putting it in place of the x. So instead of 3x to the 7th, what's it going to be? So I'm going to write, it's going to be 3a to the 7th. So I'm going to write h of a is equal to what? 3a to the 7th minus what? Talk to me now. 10 what? I don't hear anybody talking. 10a to the 4th, right? Plus 3 what? A, and then just minus 11. And that's it. That's the answer. All they're trying to do is just show you how to replace the x with whatever they want you to replace it with. That's all they're trying to show you, okay? Here's another one that's even weirder than that one. That's part A. This is part B. So they use a j. That's weird. I've never seen a function with a j in front of it, but that's what they did. So j of c minus 5. It's the same thing as this. It just looks a little weirder. If j of x equals, now we will have to do a little bit of math with this one, plus 4. Okay, now again, the key to today is to look at this and try to understand what they're asking you to do, all right? And then we just do it. So what are they asking you to do? You want to evaluate or find j of c minus 5. Say it, Sam. Replace what? Yeah, or replace the x with the c minus 5. Yeah, take that c minus 5, and instead of j of x, it's j of c minus 5. Instead of x squared, what's it going to be? It's going to be c minus 5 squared. What do we have to do with that c minus 5, though? Put it in parentheses and then put that outside parentheses, yes. Minus 7 times what? C minus 5. You see how easy it is? It looks confusing, it looks hard, but really it's actually kind of easy. Since we're running out of time, I'll let you do the math on that. All right, I'm not going to do that right now. That's not really what we're trying to learn. I got one more thing. All right, and man, I wish I had 5 more minutes than I have. I got 5 minutes, but I wish I had 10. But I think we can get this done because I want to finish this lesson today. Example, again, this one just says state, we're going to go back to that domain and range thing. Actually, we're just doing domain. State the domain of each function. I'm not going to write that down, so here it is. Here's A. And now we write it in that function notation. That's what that f of x thing is. All right, it's function notation. Now, check this out. This is kind of weird. Over x squared minus 4x. Okay, look at the top. Is there any numbers that I'm not allowed to put in for x on the top? Like, I can cube a negative number, right? What about 5? Can I take any number multiplied by 5? Yeah, can I add those together? Yeah, that's fine. So, it looks like the top, I could put any number for x that I want. What is that for the domain? I could put any number. That's all the real numbers. It's the R, right? All the real numbers. So the top is all the real numbers. Now, here's the tricky part. When you have a fraction, tell me something that you learned about fractions as far as the denominator is concerned. So what if I had this? 5 divided by 0. What is 5 divided by 0? Is it? Who's got a calculator? Anybody got a calculator? You got a computer. Put 5 divided by 0. That's right. You cannot have 0 in the denominator. So check this out. So this, talk to me, listen. This cannot be what? 0. This cannot be 0. So watch what I'm going to do. I'm going to do a little math here. So x squared minus 4x cannot be 0. You with me? All right. It can be smaller than 0, right? That whole denominator can be negative. Can you have a negative denominator? Sure. Can you have a positive denominator? Sure. You just can't have what? 0 as a denominator. So we set this so it cannot equal to 0. And I want to find what x values can you not use. All right. So far on the top, I can use all the real numbers, but I also got the bottom to worry about. All right. So let's do this. I don't know if you remember this, but let's do it anyway. I'm going to factor out greatest common factor. So what's common with both of these? X. Factor out an x, you get x minus what? 4. And that cannot equal 0. Not done. Hold on. Pack up when the bell rings. So look at this. When these are multiplied together, so x cannot equal 0, and what else? X minus 4 cannot equal 0, and that means x cannot equal what? 4. So here's your two restrictions. Your real numbers can be any real number except for whatever makes the denominator 0. What makes the denominator 0?
It's 4.
If x was 0, it would make the denominator 0. And if x was what? 4, it would make the denominator 0. Hang on just a second. Watch this. What if it was 0? What's 0 squared? 0 minus 0. That would make that a 0, wouldn't it? Put a 4 in here. 4 squared is what? 16. Minus 4 times 4 is 16. 16 minus 16 is 0. So it can be all the real numbers. The domain is all the real numbers except for what? 0 and 4. Here's your homework. Section 1.1. That's on pages 10 and 11. You're doing 17 to 49 odds, just the odds. That looks like a lot, but when it's just the odds, it's not that many. Okay, there it is right there. That's your homework. Everybody good? All right. I'll keep it up there.